February 1945, the Hurtgen Forest. The snow fell in silence, muffling the world beneath a blanket of white that seemed almost gentle until the sound began. It started as a whisper, then a growl, then an unmistakable roar that every soldier on the Western Front had learned to recognize in an instant. 1,200 rounds per minute, a mechanical scream that didn't pause to breathe. The German MG42, Hitler's Buzzsaw, tearing through the frozen air with a rate of fire so rapid that individual shots blurred into a single, continuous howl. American infantrymen pressed themselves into the earth, faces buried in mud and ice, feeling the rounds snap overhead like invisible whips. Some of them closed their eyes, others simply waited, counting seconds, praying the traverse would swing away from their position. In those terrible moments, crouched in foxholes along the Belgian-German border, every GI understood one simple truth. The Germans had built a machine that rewrote the mathematics of survival. But what those soldiers didn't know, what even their commanders barely understood as they radioed desperately for support, was that back home in the fluorescent-lit workshops of Springfield Armory and the drafting rooms of Aberdeen Proving Ground, American engineers were already tracing blueprints of that very weapon. They were measuring it, testing it, calculating its genius. They were preparing to copy it, bolt for bolt, spring for spring. By war's end, America would create its own version, a weapon that looked nearly identical, that promised the same devastating firepower. They would call it the T-24, and in the supreme confidence of American industrial might, they believed they could improve upon German engineering, adapt it to American methods, make it better. They forgot only one thing, a single detail, barely worth mentioning in the technical specifications. A detail so small that it seemed insignificant in the grand calculus of weapon design. But that one forgotten detail would mean the difference between a weapon that worked and a weapon that failed, between life and death, between victory and obsolescence. The MG42 was born not from inspiration, but from desperation. When Hitler's armies surged into Poland in September 1939, they carried with them the MG34, a weapon considered among the finest machine guns in the world, precisely manufactured, elegantly designed, capable of 800 rounds per minute. But as the Wehrmacht pushed deeper into Europe, into the steppes of Russia, into the deserts of North Africa, the MG34's elegance became its weakness. It required skilled machinists, expensive materials, and time-consuming production methods. Each receiver was milled from solid steel, a process that demanded precision and resources Germany increasingly could not spare. By 1941, with armies bleeding men across 3 continents and factories struggling to keep pace with attrition, the German High Command issued a directive: create a machine gun that could be mass-produced, stamped from sheet metal like automobile parts, assembled by semi-skilled workers, yet maintain or exceed the MG34's firepower. The result, introduced in 1942, was the Maschinengewehr 42, the MG42. It was brutal in its simplicity. The receiver was stamped and welded, not milled. The bolt system used a roller-delayed blowback mechanism that was mechanically efficient and frighteningly fast. The barrel could be changed in seconds by a single soldier, no tools required, allowing sustained fire that would melt the barrels of other weapons. And the rate of fire, 1,200 rounds per minute, 50% faster than the MG34, nearly double that of American machine guns. When fired, the MG42 didn't sound like a gun. It sounded like fabric tearing, like a saw blade hitting metal, like something industrial and inhuman. Allied soldiers called it Hitler's Buzzsaw, Hitler's Zipper, the bone saw. In German, they called it Hitlersäge. Its sound alone could pin down entire platoons, men paralyzed not by bullets but by the psychological weight of knowing that to move was to die. American forces first encountered the MG42 in significant numbers during the Italian campaign of 1943, at Salerno at Anzio in the mountains south of Rome, GIs learned what it meant to advance into that terrible sound. After-action reports filled with descriptions of suppression unlike anything experienced in training. Squads frozen in place, unable to maneuver, watching men cut down the moment they attempted to flank or rush a position. The MG42 transformed defensive tactics. A single gun, properly positioned, could control hundreds of yards of frontage. Two guns, mutually supporting, could stop a company. The mathematics was simple and brutal. 1,200 rounds per minute meant 20 bullets per second, a stream of lead so dense that it didn't require precise aim, only general direction. The cone of fire was wide enough, the volume high enough, that movement became suicide. In the fall of 1943, an intact MG42 was captured near Monte Cassino and shipped to Aberdeen Proving Ground in Maryland. There, a team of ordnance engineers disassembled it with the care of surgeons, measuring tolerances, photographing components, testing metallurgy. What they found impressed them. The weapon was cruder than American designs, rougher finishes, visible welds, stamped parts where American doctrine demanded milled precision, yet it functioned flawlessly. The roller-delayed bolt system was elegant in its mechanical efficiency. The quick-change barrel was ingenious, the rate of fire was devastating. In firing tests, the captured MG42 performed with remarkable reliability, continuing to function even when deliberately subjected to mud, sand, and extreme temperatures. The American observers noted everything. They documented the brilliance of German engineering pragmatism, the way necessity had forced innovation, the manner in which wartime pressure had produced a weapon that was both cruder and more effective than peacetime thinking would have allowed. The decision was made. America would build its own version, not a direct copy, of course. American pride and doctrine demanded modifications, but a weapon clearly based on the MG42's operating principles. The project was designated the T-24 machine gun. Engineers at Springfield Armory began adapting the roller-delayed system to American manufacturing standards and American ammunition. Because while the Germans used the 7.92 cm Mauser cartridge, America was committed to the 36 Springfield round, a longer, more powerful cartridge that had served since World War I. The T-24 would chamber 36, delivering MG42 firepower with American ammunition. It seemed logical, even inevitable. The prototype appeared in 1944, looking remarkably similar to its German parent, the stamped receiver, the quick-change barrel, the distinctive profile. In initial tests, it achieved rates of fire approaching 1,100 rounds per minute. Close enough. American enough. Better, the engineers believed, because it fired a more powerful cartridge. But as testing continued through 1944 and into 1945, problems emerged. The T-24 jammed, not occasionally, but frequently. The roller delay system, which had performed flawlessly with 7.92mm Mauser ammunition in the German original, proved temperamental with 30.06 rounds. Extraction failures became common. Cases ruptured. The weapon overheated faster than expected. Engineers made modifications, stronger springs, modified extractors, improved chamber dimensions, but each fix seemed to introduce new complications. The weapon that had looked so promising on paper, that had seemed like a straightforward adaptation of proven German technology, refused to achieve the reliability that made the MG42 legendary. By late 1945, with the war in Europe over and victory in the Pacific secured, the T-24 program was quietly shelved. The weapon that was supposed to give America its own Buzzsaw, its own 1,200 rounds per minute supremacy, was relegated to the footnotes of ordnance history. For years afterward, military historians and gun enthusiasts debated what went wrong. Some blamed American manufacturing tolerances, suggesting that US factories couldn't replicate the precise dimensions required by the roller delay system. Others pointed to insufficient testing or rushed development timelines. A few suggested that the 3006 cartridge itself was incompatible with the MG42's operating mechanism, that the longer case and higher pressure created extraction problems the German design never encountered. All of these explanations contained elements of truth, but they all missed the fundamental issue, the single detail that German engineers had understood instinctively but American designers overlooked in their confidence. The answer lay not in the gun itself, but in the ammunition, specifically in the cartridge case. The German 7.92mm Mauser round used steel cartridge cases, not brass. This wasn't a choice born of superior metallurgical insight. It was pure wartime necessity. Germany, blockaded and resource-starved, lacked sufficient copper to manufacture brass cartridge cases for millions of rounds. Steel was abundant, so German ammunition factories stamped out steel cases, applied a thin lacquer coating to prevent rust, and loaded them with powder and projectile. The steel cases were harder than brass, less malleable, less forgiving. They didn't expand and contract the way brass did during firing. They required more aggressive extraction. And the MG42 had been designed from the very beginning to handle steel cases. Its chamber dimensions, its extractor strength, its roller delay timing, every aspect was calculated around the specific properties of steel-cased ammunition. American ammunition, by contrast, used brass cases exclusively. Brass was traditional, proven, and America had copper in abundance. Brass cases were more reliable, easier to reload, gentler on chamber walls. In the American industrial mindset, brass was simply superior, and there was no reason to compromise. When engineers adapted the MG42 design to fire 3006 ammunition, they naturally assumed they would use standard American brass-cased rounds. They adjusted chamber dimensions for the longer cartridge. They modified the bolt system for the increased pressure, but they didn't fully account for the different expansion and extraction characteristics of brass versus steel. Brass, being softer and more elastic, expanded more during firing, gripping chamber walls more tightly. The extraction system that worked perfectly with steel-cased 7.92mm rounds, designed for harder, less clingy cases, wasn't quite aggressive enough for brass-cased .3006 ammunition, fired at extreme rates. The timing was fractionally off. The pressure curve was different, and in a weapon firing 20 rounds per second, fractional differences compound into catastrophic failures. The irony was profound. American engineers had copied the weapon almost perfectly, had replicated its mechanical genius, had even attempted to improve it by chambering it for a more powerful cartridge. But they had copied it into an ammunition ecosystem for which it was never designed. They had transplanted a machine evolved for steel into a garden of brass and wondered why it withered. The Germans, forced by scarcity to use inferior materials, had accidentally created a system optimized for those materials. The Americans, blessed with abundance and superior resources, had overlooked the invisible optimization, the unwritten assumption buried in every measurement and tolerance. Some experimental batches of steel-cased 3006 ammunition were eventually produced for testing. When fed steel-cased rounds, the T-24's reliability improved dramatically. Jam rates dropped. Extraction failures became rare. The weapon began to perform as intended, delivering sustained high-rate fire with acceptable reliability. But by then, the war was over, budgets were shrinking, and military priorities were shifting. The institutional momentum behind the T-24 had dissipated. American ordnance planners were already looking toward the future, toward new calibers, toward concepts like the universal machine gun, toward what would eventually become the M60. The T-24, with its specific requirement for non-standard ammunition, was an evolutionary dead end. It was shelved permanently, a footnote, a might have been. The soldiers in the Hurtgen forest never knew any of this, of course. They never knew that American workshops were trying to replicate the weapon that terrorized them. They never knew about the T-24, about the tests at Aberdeen, about the engineers puzzling over extraction failures and jam rates. They knew only the sound, that terrible, unmistakable sound of 1,200 rounds per minute, the sound that meant death was sweeping toward them at 20 bullets per second. Some of those men would survive the war. They would come home, would eventually read about American industrial might, about the factories that outproduced Germany 10-1, about the overwhelming material superiority that crushed the Axis. And perhaps a few of them, reading those accounts, would remember lying in frozen mud while the buzzsaw screamed overhead and would wonder quietly why, if America could build anything, if American engineering could overcome any challenge, they had never heard that sound coming from their own side of the line. The detail was small, a difference in materials, a choice of steel over brass, a decision made not by engineers but by economists responding to copper shortages. It was the kind of detail that would never appear in a technical manual's headline specifications. Bore diameter, rate of fire, weight, effective range, these were the numbers that mattered or seemed to matter. But war is fought in the invisible spaces between specifications, in the unwritten assumptions, in the details so fundamental they seem hardly worth mentioning. The Germans understood this, not through wisdom, but through necessity. Scarcity had forced them to build weapons that worked with what they had, not with what they wished they had. America, abundant in resources and confident in its superiority, attempted to impose its own standards onto a foreign design, and discovered too late that genius cannot always be translated without loss. In the end, the MG42 remained a German weapon. The sound remained theirs. The buzzsaw never spoke with an American accent. And in that failure, in that single forgotten detail about the hardness of cartridge brass, lies a truth larger than weapons design. Abundance creates its own blind spots. Confidence breeds assumption. And sometimes the very advantages that should guarantee success, superior resources, better materials, industrial might, can become invisible barriers to understanding what made something work in the first place. The Germans built the MG42 because they had to. The Americans tried to copy it because they could. But between necessity and capability lies a gap that cannot always be bridged by engineering alone. Sometimes the detail that matters most is the one you never thought to copy.